Hello, my name is Fabio, and in this brief video I shall outline the operation of the mechanism I have analyzed for my Applied Mechanics 1 project. This mechanism is an offset slider and crank mechanism. It's offset, meaning that the crank is not on the same level as a slider. The operation of such a mechanism can be analyzed, as shown in my report, by adding two extra imaginary sides, one of fixed length and one of changing length, to the vector loop diagram. Basically, the way in which this works is that the crank has a freedom of rotation of 360 degrees around this pivot, and the slider has a freedom of movement left and right inside a contained space. This means that the slider is forced to move only horizontally, left or right. The advantage of having such a mechanism compared to a normal slider crank, where the crank would be on the same exact level as the slider, is that because of the geometry of certain mechanisms, the ratio of forward stroke to backward stroke is not unity, meaning that one of the two strokes, as you can see, is quicker than the other one. Many applications of such a mechanism are found, especially in industry, where time optimization is the most important thing. This is done, for example, in a fast cutting mechanism where some kind of cutter, maybe a laser, maybe a blade, is put in place of the slider and made to move by the crank. In this case, in some kind of assembly chain, another mechanism, another machine, providing whatever needs to be cut from the side, will be able to provide more than if this was made by a normal slider crank, since the provision of whatever needs to be cut can be done in less time because of the fact that one of the two cycles is quicker than the other. Another application, still in industry, is packaging. If, for example, I have an object that needs to be packed in some packaging, which is put here, this object can be pushed by the mechanism into the packaging, and since it's quicker to retract, more objects per time can be packed. So here's how this works. As you can see, the crank rotates, the slider slides, velocity changes between forward stroke and backward stroke. As far as position, velocity and acceleration analysis are concerned, you can find everything in the attached document. Thank you very much.